Welcome to this video. In this video, I am going to give you some introduction of the probability, some of the terms that we used in the probability, and then give some simple, very basic examples on finding the probability of an event. Okay. So before I give you the definition of probability, I'm going to talk about some of the terms that we use in a probability. Number one is 4.1 is sample space and the probability. So the probability can be defined as the chance of an event occurring. So what do you mean by experiment or trial? Is any procedure that can be repeated and has a well-defined set of possible results. For example, you can toss a coin. So toss a coin. If you toss a coin, let's say 5 times. If you toss a coin 5 times, we call this is an experiment. So the experiment here is tossing a coin 5 times. Okay, but how many trials does it have? You flip the coin 5 times. That is a 5 trials, right? This whole thing is one experiment, but the trials are 5 trials. Okay. An outcome is the result of a single trial of a probability experiment. For example, when you toss a coin 5 times, then you may get head or tail, head and then tail, right? On the first trial, the outcome is H. The second trial, outcome is tail. The third trial, outcome is H, the head. The fourth trial, outcome is head, and the fifth trial, the outcome is tail. So this is just a sample that I took. So it could be anything between head and tail in any trial, right? All of them can be head, all of them could be tail. So some of them may be head or tail, they mixed together. So but the outcome is whatever you got in a single trial of an experiment. That is called outcome. So the collection of all possible outcomes in an experiment is called sample space. Okay. For example, sample space is the collection of all possible outcomes. All right. So what could be a sample space if you toss a coin once? The sample space could be head or tail, right? So if you toss 2 coins together, then it could be S equals HH. The first coin can show up a head, second coin can show up head. HT, meaning the first shows head, second shows tail. TH, first tail, second head, and then TT. So this can be this is the total possibility when you toss 2 coins together. Now let us do this example. Write the sample space when you toss a coin. We did that already. That is when you toss a coin, these are the possibilities that the coin can show up. Roll a dice. When you roll a dice has 6 faces, right? So with 1 dots, 2 dots, 3 dots, like that. So this is the sample space when you toss 1 dice. Roll 2 dice. When you roll 2 dice, then the first dice can show up 1, second dice can show up 1, first dice 1, second dice 2, and then so on up through 6. Similarly, first dice can show up 2, second dice can show up 1, first dice can show up 2, second dice can show up 2, and then so on. And if you organize, this is how you list all the possibilities when you roll 2 dice together. Okay, so here the first number in each of these pairs stands for the outcomes of the first dice, and the second number stands for the outcomes of the second dice. That's what it says, right? MN stands for M in the first dice and N is the second dice. By the way, when a coin is tossed twice, this is not complete. So the another sample space it is asking is, right, the sample space when a coin is tossed twice. This is what it will look like. So when 2 coins are tossed together, or when a coin is tossed twice, this is what the same sample space. So that will look like the first coin, the first trial has head, second trial has head, first trial has tail, head, second trial has tail, and so on. This is what you will see when two coins tossed together or a coin tossed twice. Okay. So the next thing we want to talk is an event. So event consists of outcomes. Event is basically the subset of sample space. Okay, an event can have simple or compound, meaning an event is called simple event if it has only one outcome, and compound event if it has more than one outcome. Meaning, so an event consists of outcomes from sample space. It may have only one outcome or more outcome from the sample space. Let's see an example. When a dice is rolled, write the event O that has an odd outcome. When a dice is rolled, can you think of a sample space? Sample space will be 1, 2, 3, 4, 5, 6. These are the possible sample space. By the way, the sample space is denoted by S, and this is enclosed by the curly braces with each of the outcomes separated by comma. This is how we write the sample space. Okay, so if you denote O as the odd outcome, so what are the odd outcomes? 1, 3, and 5, right? So this is what I denote by O equals to 1, 3, 5. And write an event A that has number greater than 4. This event A has number greater than 4, that is 5 and 6, right? That is that 5 and that 6. And event P is the prime numbers. So that is prime outcomes is 2, 3, and 5. We are basically taking outcomes from sample space S. Okay, now look at this. So equally likely event are events that have same probability of occurring. So when you roll a dice, then these are the possibilities, right, you can get. And when you roll a dice, all the outcomes are equally likely to occur. That's why we call equally likely event. If you toss a coin, then the sample space will be head and tail, right? So there is equal probability or equal chance of happening head or tail. So these events or so here, if you select an event A equals to say H, right, and then B equals to say T, these two events are equally likely to happen, right? So these two events are equally likely to happen. Similarly, if you roll a dice, then all the single events are equally likely to happen. It can happen 1 or 2 or 3, so they have equal chance. Now, let me talk about if the events are joint or disjoint. Look at this, event O and event A, they are joint because 5 is common to both of these, right? And event A, similarly event O, A, and P, they are also joined because they all have 5 in common. Next is the tree diagram. Is a device consisting of line segments emanating from a starting point and also from the outcome point. It is used to determine all possible outcomes of a probability experiment. For example, if a family plans to have 3, oh, by the way, there is a typo there, plans to have 3 children, the first child can be boy or girl, second child can be boy or girl, or third child can be boy or girl. This is how you draw the tree diagram. So the first child, it can be either boy or girl. So first child can be boy and the second child can be boy or girl. Similarly, if the first child is girl, second child can be boy or girls. And similarly for the third child. And how do you collect all the outcomes to write the sample space? To write the sample space, what you do is B, 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 right? B, 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 meaning first child, second child, and third child can be all boy. And another outcome could be B, B, G, right? So B, B, G, you go that way. Meaning the first child can be boy, second boy, and the third girl. And then you list all those outcomes like that. So tree diagram can be helpful sometimes to list the all possible outcomes. Let's look at that. If a coin is tossed twice, list all the possible outcomes in the sample space. So if you toss a coin twice, so the first outcome, the first coin can be, or the first toss can be head or tail, right? Now the second toss can be, the first toss is head and second toss can be head or tail. Similarly, if the first toss is tail, then the second toss can be head or tail. Now how do you collect that? Is HH, that is HH, HT, right? That is HT. Similarly, TH and then TT. You see that? So similar is I did the tree diagram for the boy and girls here. These are the outcomes if you collect all together, BBB, BBG, and so on. Next is now the definition of the probability. So how do we define the probability? Is probability of an event E, we denote by PE, is the number of outcomes in the event E divided by the total number of outcomes in the sample space. Okay, so you need to know how many outcomes will be in the sample space if you want to find the probability of an event. Okay, so this is the formula. PE equals to NE, meaning number of outcomes in event E, over NS, meaning number of outcomes in the sample space S. Let us do some examples here. When you draw a card from a pack of 52 cards, what is the probability of getting a red card? So how do we find out? For the red card, is the probability of a red card is number of outcomes is number of red cards over number of total number of cards. Let's say C is the total number of cards. How many red cards are there? If you pick a pack of 52 cards, half of them are red and half of them are black, right? So see, there are 26 red cards. So the probability is 26 red cards, total number of red cards over total number of cards is 52. This is what you do. And if you divide by 26, you will get 1/2. Similarly, how many ace cards are there? So probability of ace is equals to number of ace cards divided by total number of cards, number of total cards, right? So there are 4 ace cards, so 4 out of 52 is 113. Similarly, there are 13 clubs, so 13 out of 52 is 1/4 is the probability of picking a club if you pick one card. And similarly, the probability of king is 4 out of 52, that will be 1/3 again. Let us do one more examples there. When you roll 2 dice, what is the probability that the sum of number on the top is 4? So if you roll 2 dice, do you remember what are the outcomes look like? The sample space look like 1 1, 1 2, and so on. Similarly, 2 1, right? And then 2 2, and then so on. So similarly, and then finally you'll get 6 1, and then 6 2, and so on, right? Now, you want to find out what is the probability of getting the sum 4. How many outcome will have sum 4? That will be 1 3, right? 2 2, and 3 1. These are the only outcomes from the sample space that has sum 4. So how many of them are there? There are 3. But how many total outcomes are there? So the beginning one has 6 outcomes, beginning 2 has 6 outcomes, and so on. So the total will be 36, right? So it will be, so 3 of them have sum 4 and the total is 36. So the probability is 3. The number of outcomes with sum 4 is 3 and total outcomes is 36. So 3 over 36 is 1 over 12. This is what you get. Similarly, for the sum 7, these are the outcomes that has sum 7. Okay, how many? 1 2 3 4 5 6. So 6 out of 36. The total is 36. 6 out of 36 is 1/6. Similarly, let's look at the 9 or 10. How many outcomes have 9? So 1 2 3 4. So sum 9. There are 4 outcomes with sum 9, and then 1 2 3 3 outcomes with sum 10, right? So the total number of outcomes in sum 9 and or sum 10. So we will see what is the or there later, okay? But for now, you count all of them, because if they are repeated, you don't count there, okay? So they are not, none of them are repeated there. So you counted them and then counted them. So totally 7 out of 36. This is how you find out the probability of an event. So total number of outcomes in the event divided by the total outcomes, okay? Now let us talk about the probability rules there. So the probability of an event is a number that is between 0 and 1. If an event is cannot happen, then the probability will be 0. If the event is sure to happen, the probability will be 1. And the sum of the probabilities of all outcomes in a sample space is 1. So what does that mean? Meaning, in a sample space, if you add the probability of each of the outcome, let's say if you toss a coin, then sample space will be head and tail, right? What is the probability of head? Is there is 1 head out of 2, and probability of tail will be 1 tail out of 2 outcomes, right? If you add these two, then the sum will be 1/2 plus 1/2 is 1. That's what it is saying. The sum of all probability of all outcomes is 1. If an event cannot occur, the event contains no members in the sample space, its probability is 0. For example, if you toss a coin, then what is the probability that you get 1? There is no 1 in the coin, right? The sample space has H or T. So probability of 1 is 0 because there is no 1 in that. Okay. Similarly, if you roll a dice, what is the probability of head? If you roll a dice, it is 0, right? Because there is no head in the dice. So there are just 1, 2, 3, 4, 5, 6 in the dice. So if you are sure that the event cannot occur, then the probability is 0. And if you are sure that the event occur, then the probability is 1. For example, if you toss a coin, what is the probability that you get head or tail? Right? Head or tail, it is sure to happen, right? Either head or tail. So the probability is 1. So that's how these are the rules of probability. Now let us talk about the complementary events. For an event E, the set of outcomes in the sample space that are not included in the outcomes of an event is called the complement. So the complement of E is generated by E bar. Okay, and the probability of the complementary event is P E bar is equals to 1 minus PE. Okay, let us take a very simple example before I go through the example there. So if you toss a coin, what is the sample space, H or T? Right? What is the probability that of head is, how many head are in the sample space? 1 divided by, how many are in total? 2. But if you want to find out the complement of head, this is how you denote probability of H bar. That is 1 minus probability of H. This is how you find, right? So 1 minus 1/2, that is also 1/2, right? So probability of complement of head is 1/2 here when you toss one coin. Now, there is another way to find out the complement, right? What is the complement of H means? H bar, basically complement of H is everything except H is the same as probability of T, right? Everything except H is the complement of H. So probability of T is, how many tail are there? 1 divided by the total is 2, so 1/2. So either way you will get the same answer. See, the complement way or listing the one that are not in the head, not head. Let us look at this example number 7. Okay, so in example 7, tossing a die, the event O of odd outcome is 1, 3, 5. Because when you roll a dice, the sample space is 1, 2, 3, 4, 5, 6. So which one are the odd outcomes? 1, 3, and 5 are the odd outcomes. This is how we denote. Now, what is the complement of odd? Is 1 minus PO. This is how we find out, right? That is 1 minus, what is the probability of O here? Probability of O is, there are 3. And in the sample space there are 6, so 3 over 6. So complement of O is 1 minus PO, that is 1 minus 3 over 6, that is 1/2. For this is same as finding the even numbers, right? Because what is the complement of O bar is same as probability of E, right? Because if you remove all the odds, that is the complement. That what is left is 2, 4, and 6. So that will be also 3 over 6, that is 1/2. So finding the complement, there are two ways to find out the complement. One way is complement of an event. One way is you do 1 minus probability of that event, and another way is list the event that is the complement. So basically you can list the event like, you can write E, or you can say O bar equals to 2, 4, and 6. So probability of O bar is same as the event E, right? That is 3 over 6 because there are 3 outcomes. Look at example 8. Selecting a day of the week, the days begin with T is Tuesday and Thursday. So the day that do not begin with T will be probability of T bar, that is 1 minus 2 over 7, because the probability of T here is, there are 2 days starts with T and the total number of days is 7, that is probability of T is 2 over 7. So probability of complement of T is 1 minus 2 over 7, 5 over 7. But another way to do that is T bar is same as not T. T bar is same as not T. Not T is not the Tuesday and Thursday. So Sunday, Monday, Wednesday, and then Friday, and then Saturday. There are 5 of them, right? So the probability of T bar is 5 over the total number of days is 7. You can do this way too. So there are 2 ways to find the probability of a complement. Let's do example number 9. tossing two coins, the event A with no heads will be TT, because when you toss two coins, the outcomes will be, the sample space will be head in the both coin, head and on the first, tail on the second, tail on the first, head on the second, and then tail, right? So the event with no heads is just this one, right? TT. And the complement of event with no head is PA bar 1 minus, because the probability of A bar is 1/4, because there is only one outcome there, right? And then there are total 4 outcomes there. And PA bar will be 1 minus 1/4, that is 3/4. So another way of doing that is just list A bar. By the way, there should not be A bar. This is just no head, that is H. A equals to TT, okay? So, but A bar will be HH, HT, and then TH, right? So, A is no head. So, A bar will be except no head, meaning at least one head, right? So, these 3 outcomes have at least one head. So, you can write that way. So, probability of A bar will be 3/4. Let's look at example number 11. So in a study, that it was found that 23% of the people surveyed said that the vanilla was their favorite ice cream. If a person is selected at random, find the probability that the person's favorite flavor of ice cream is not vanilla. So not vanilla means the probability of not vanilla is 1 minus probability of vanilla, that is 1 minus 0.23, that is 0.77, that is 77%. Okay, so this is how you find out the probability of the complement. Let's talk about the empirical probability. Classical probability assumes that all the outcomes are equally likely to occur, but empirical probability relies on actual experience to determine the likelihood of an outcome. So let's see this example. In an experiment, 100 people, if 56 favors flying for travel, 20 favors driving, and 24 favors public transport, the probability that a person selected randomly favors flying. So how many person favors flying? Probability of flying equals to number of people favoring flying over total number of people, T, right? So that will be number of people favoring flying is 56. That will be 56, and the total number of people surveyed was 100. That is 56 over 100 is 0.56. This is how we find out this answer. Okay, so that's why under the empirical probability, the probability of outcome of an event is number of favorable outcomes over total number of trials, okay, or frequency for that class over total number of frequency. That's what you use. Okay, let's look at this example. From the following data, find the probability that if a person is selected randomly, he has type O blood. How many has type O blood? Is 21 divided by the total is 50, right? Type A or B. How many have A or B? 22 plus 5 is 27 divided by 50. Type A, not type B. Neither type A nor type B. Neither A nor B means A, B or O, right? So that will be 2 plus 21. It is just the complement, right? 1 minus number of A or B divided by total number of outcomes. That's what you do. So basically this bar must be the for whole. Probability of not A or B. That is 1 minus A or B divided by the total, right? So that's how you do 1 minus 22 plus 5, because this is A or B, right? And then since you are finding the complement, neither nor, so you subtract to find out the probability, you subtract that from 1, right? Basically what you are doing here is probability of A or B complement is equals to let me do 1 minus, so 1 minus probability of A or B. That is 1 minus, what is probability of A? Probability of A or B is 22 plus 5, right? 22 plus 5 divided by 50. That is 1 minus 27 over 50. That is 23 over 50. That's what you get. Okay? So, not type AB. Not type AB means except 2, right? So, what are those? That are 22 plus 5 plus 21. That is 48. 22 plus 5 plus 21 will be 48. So, one way to do that is 48 over 50. Another way is 1 minus, probability of AB complement is 1 minus probability of AB, 1 minus 2 over 50. So this is how you find out. Okay. So let us do this example. Use the following data to find out the probability that if a patient is selected randomly, he stayed. So this example is basically they were doing an experiment that if a person broke a leg, how many days he will spend in hospital. Okay. So they were actually doing experiment for 127 people who broke a leg, and then they were collecting the data. So 15 people stayed 3 days in a hospital, 32 people stayed 4 days, 56 people stayed 5 days, 19 people stayed 6 days, and 5 people stayed 7 days in the hospital. Okay. Now you want to answer the question. What is the probability that the person spent exactly 5 days? So how many people? How many people are there who spend 5 days? 56. So 56 over 127. He said 6 or fewer. 6 or fewer means you need to add these, and this. So P3 plus P4 plus P5. Oh, it says 6 or fewer. Let's say, I messed up that one. So you should do plus P6 as well. Okay, because it says 6 or fewer. So less than 6, less than or equal to 6, less than or equal to 6. That's what the 6 or fewer means. Okay. So P3 plus P4 plus P5 plus P6. So how much would that be? That will be 15 plus 32 plus 56 plus 19, right? Over 127. So how much would that be? That will be 122 over 127. This is what. So since it says 6 or fewer, you need to add 6 as well, probability of 6 as well. If it was saying just fewer than 6 days, then you do P3 plus P4 plus P5, not P6. In that case, that would be the right answer. Okay. Since it says 6 or fewer, so you need to count 6 as well. Next, he said at most 4. At most 4 means 4 or less, right? That is 4 or less. So how do you do that? Probability of 3 plus probability of 4. That is this one and this one, right? And then you do you add them. Probability of 3 plus probability of 4, because 3 has 15 plus 32 will be 47 over 127. And at least 5 means 5 or more, right? That is 5, 6, and 7. Probability of 5, probability of 6, probability of 7. That will be, if you add that, 56 plus 19 plus 5, you will get 80 over 127. That's all about the introduction of the probability and finding the probability of some event.